Hello, everyone. In this class, we will learn the concepts of the external characteristics and regulation characteristics of synchronous generators. When a synchronous generator operates stably under symmetrical load, maintaining constant speed, frequency, and power factor under those conditions, the terminal voltage U, load current I, and excitation current IF are the three main operating parameters. They can all be measured during operation, and they are interrelated. When one parameter is kept a constant, the functional relationship between the other two parameters is called the operating characteristic. The operating characteristics of a synchronous generator include no-load characteristics, short-circuit characteristics, external characteristics, and regulation characteristics. This section will analyze and discuss the external characteristics and the regulation characteristics of these two types of characteristics. 1. External characteristics. External characteristics refer to the relationship between terminal voltage U and load current I when the synchronous generator operates at rated speed, and constant excitation current IF and constant power factor cosine phi. That is, the relationship U equals to F of I is called the external characteristic for purely resistive loads. For example, cosine phi equals to 1 and purely inductive loads. Cosine phi lags under constant excitation current as the armature current increases. The demagnetizing effect of the armature reaction strengthens, and the leakage reactance drop increases, causing the terminal voltage to decrease for inductive resistive loads. For example, cosine phi leads when the load capacitive reactance is greater than the synchronous reactance. The armature reaction shows a magnetizing effect. As the armature current increases, the terminal voltage increases instead, as shown in the figure. Voltage change rate. The terminal voltage of the generator changes with the load current. When maintaining rated operation, constant excitation currents I sub Fn and rated speed. Unloading the generator completely, the terminal voltage of the generator will change from the rated voltage Un to the no-load electromotive force E0. The magnitude of the voltage change can be expressed by the voltage change rate, delta U, which is delta U equals to E0 minus Un divided by UN times 100. Delta U is one of the performance indicators of the generator. To prevent the generator from tripping due to faults and cutting off the load, causing excessive voltage rise and insulation breakdown, delta U should not exceed 50%. 2. Regulation characteristics. As can be seen from the external characteristic curve, when the load changes, the terminal voltage of the generator also changes. For power users, it's always desired that the voltage is stable. Therefore, to keep the generator voltage constant, the excitation current must be adjusted accordingly with the load changes. Regulation characteristics refer to the relationship between excitation current IF and load current I when the voltage U is constant and the power factor cosine phi is constant under the condition of rated speed n, which is the IF equals to F of I curve. For purely resistive and inductive resistive loads, to compensate for the demagnetizing effect of armature reaction and the leakage reactance voltage drop, in order to maintain the terminal voltage of the generator constant, it's necessary to increase the excitation current accordingly as the load current increases. Therefore, the regulation characteristic curve is rising. For capacitive resistive loads, to counteract the direct access magnetizing effect of the armature reaction and maintain the terminal voltage of the generator constant, is necessary to decrease the excitation current accordingly as the load current increases. Therefore, the regulation characteristic curve is descending, as shown in the figure. Thinking question 1. Analyze the reasons for changes in the external characteristic curve and the regulation characteristic curve of the synchronous generator. Answer the reasons for changes in the external characteristic curve of the synchronous generator are that for purely resistive loads, which is cosine phi equals to 1, and inductive resistive loads, which is cosine phi lags under constant excitation current. As the armature current increases, the demagnetizing effect of the armature reaction strengthens, and the leakage reactance drop increases, causing the terminal voltage to decrease. For capacitive resistive loads, cosine phi leads when the load capacitive reactance is greater than the synchronous reactance. The armature reaction shows a magnetizing effect. As the armature current increases, the terminal voltage increases instead. The reason for changes in the regulation characteristic curve of the synchronous generator is that for purely resistive and inductive resistive loads, to compensate for the demagnetizing effect of the armature reaction and the leakage reactance voltage drop, it is necessary to increase the excitation current accordingly to maintain the terminal voltage of the generator constant. Therefore, the regulation characteristic curve is rising for capacitive resistive loads to counteract the direct excess magnetizing effect of the armature reaction and maintain the terminal voltage of the generator constant. It's necessary to decrease the excitation current accordingly as the load current increases. Therefore, the regulation characteristic curve is descending. In this lesson, we learned the basic concepts of the external characteristics and regulation characteristics of synchronous generators. We hope everyone will do more exercises after class to consolidate the knowledge from this lesson. This lesson ends here. Thank you, everyone.